Let's start with our today's DSA journey with this amazing visualizer by dsa.chaicode.com. Use this link to get a 7-day free trial. Okay, so today our question is longest valid parenthesis. Okay, the question states that given a string containing only the characters, the open braces and the close braces of the parenthesis, return the length of the longest contiguous substring that forms a well formed properly matches sequence of parentheses. Okay. So what does the question state? First one, this is well formed. Okay. So for a bracket to be well formed, so this is a well formed bracket, or you can say as here substring. This is a well formed substring because we had an open bracket, we had a closing bracket. Okay, so now if I just go it here, so now if I add this one here, this is not a well formed because there are one opening bracket and two closing brackets. So if at the starting we enter this, now this is a properly formed substring or bracket. So if we add this here, this opening one, this is also not because this opening doesn't have any closing. So we have this closing braces here. Now this is the well formed. So this is not a well formed. Even if we got one extra here, this is not a well formed bracket. We can, when we put closing bracket here, then it is a well formed bracket. Okay, so this is our question. So this is the opening one, this is the closing one, this is the opening one, this is the closing one, this is the opening one, this is the closing one, this is the opening one, this is the closing one, this is the opening one, this is the closing one. So this is our opening and closing brackets. Okay, suppose we are given a string like this, what we have to answer? We have to longest contiguous substring. Okay, so I think we should let's check the question. I think we should give the length of the, yes, the length of the longest valid well formed substring. So our goal is to find the length of the longest contiguous substring. Okay, so how could we this for this substring, this string, and get a good valid string, a good valid well from string. Okay, so this is our string. So what if we uses two loop? So one is the I loop and another one is the j loop, and we traverse the loop according and find out proper which is our proper well formed substring. So how could we find that? Okay, so where, let's just forget everything for now, this I and j also. So when we say a substring is well formed, when there is a open bracket, there is a open bracket, and for this open bracket in future there is a closing bracket. Okay, so if we had this opening bracket, in future we should have a closing bracket to maintain a well formed string. Okay, okay, so this is our question. We need a opening bracket at the starting, we need a opening bracket at the starting, and also we need a closing bracket in the future. Okay, we need a opening bracket, we need a closing bracket. Okay, this is our a well formed substring. Okay, so we have this opening bracket, also we have a closing bracket. So how could we calculate that we had equal number of opening bracket and also equal number of closing bracket, also there in well formed manner, any kind of uh, not any of like a bad or not well formed manner. So for this, what we can calculate it using a simple thing. The thing is simple. For every opening, this opening, we consider this character because we are given a string. So we consider this character as +1, and we consider this closing bracket as -1. We will consider this closing bracket as -1. So opening bracket is a +1, closing bracket is a -1. How did this help to us? So this is like -1, +1, -1, sorry, minus +1, -1, -1. So observe one thing in this string, okay? Observe one thing. So when we have a in this string, what is the maximum portion there which is well from this one? This is the portion which is the maximum. Also every bracket is well formed inside it. Okay, left part of this, it is not like it is not well formed. Also the right part is not well formed. So what is the total sum inside it? It is 0. +1 -1 +1 -1, it is 0. So using this formula, like opening bracket as +1, closing bracket as -1, and when we get a maximum area, okay, in this image we got this maximum area, and when we got a maximum area, the total sum of this whole area is 0. Even even we take the smallest ones, even we take the smallest ones, this will also have 0. This smallest one, this the sum of this is also 0 here. So every time there is a well formed braces, this is a well formed because everything is well formed here. So when you have a well formed bracket or braces, the whole sum is become 0. This well formed is become 0, this well formed is become 0, the whole of the thing which is well formed is also become 0. So this well formed, this portion becomes 0, this portion, okay, this portion is also become 0. Also the whole portion is also become 0. So this is our intuition observation, which is you can take any of this thing. So we have to find one area, one substring, the maximum substring, actually the maximum substring where the sum is 0. Okay, we can use two loops here, but the main thing is we achieve it. Okay, so let's take this thing here, these two. So also we have to observe one thing here, that just observe one thing. So what we are taking the opening braces as +1, the closing braces as -1. Okay, so if any of the cases we reach the closing braces -1, so if we have anything, if we have anything like anything inside after it, is it possible to have a closing bracket for this, or a well formed, well, not closing bracket, a well formed substring to this if we reach -1 here? We can't. We can't reach -1. We can't reach any well formed string if we got a -1. And what is minus 1? If we have like another closing bracket, it will also have minus 1. Even we have these two positive bracket, even if we have these two positive bracket, which will be plus 1 and plus 1, but because we are reaching the closing bracket at the first and not the opening bracket at the first, it always states that it is not possible. So one condition we could check here, which is nothing but if any time the sum is less than 0, it is not possible. If the sum is less than 0, either it minus 1 minus 2 anything, it is not possible. But if it is a plus 1, maybe it is possible or maybe it is not possible. There are two cases. If we reach a positive number, then maybe it is possible to have the sum, and or we can't find anything, any closing in the end. Okay, so we can easily get like, for if we reach any positive number, if we reach any positive number, then it is possible or not possible. So just copy this. So if the sum is greater than 0, it is possible. Possible. So if the sum is less than 0, it is clearly we can state that this it is not possible. We don't found any kind of well from bracket here, but the sum is positive. There is a possibility that we could, or maybe we cannot find it. Okay, so and when the sum is equal to 0, there is a it is the only case which is possible. Okay, so we have these three cases. We have these three cases. If the sum is getting less than 0, it simply means we reach a closing bracket before a opening bracket. If the sum is less than 0, we reach a closing bracket before we reach a opening bracket. For this reason, we say it is not possible. Okay, and if the sum is greater than 0, not possible. In the previous case, not possible for from that portion. So we have to go to the next portion. Okay, so not possible means for that index I, it is not possible to form a well found string from that index, that I index. But go to the next indexes to check if we found any possible substring. So if the sum is greater than 0, if the sum is greater than 0, for any reason, if the sum is greater than 0, it simply means we reach a positive bracket. So if we reach a positive bracket, there is a chance if we encounter a negative bracket in the future, we get a solution. Also, if we don't reach any negative bracket, we cannot get a solution for that index. So, if the sum is 0, it is possible or not possible to get a solution for that index. But if the sum is becoming 0, it simply means we got a positive bracket or a opening bracket. Also, we got a negative bracket, which is a closing bracket. And after summation of these two, we reach a 0. And this is a well from substring. So, this is our total intuition or observation. Now, this is our bracket. The brute force solution uses the brute force and the optimal one. Both uses this same sum principle, but the technique of implementing this is different. Okay, so first, the main or the core is this one, that opening bracket as this as positive one and the negative the closing bracket as the negative one. Okay, so this is our loop, this is our string. We check two pointers. Okay, the first one like starting pointer, and this j will go start from I. It will go to every index and check the if the value is positive or not. Okay, so when we start, we have to put the I here, then the j here. Okay, j will always starting from I. J will always start from I. The j always start from I. So when the j is starting from I, first we have to check that we have two if conditions, that if it is a opening bracket or not. We will use a sum, a balance, or any variable here. Let's take a sum here is at the starting it is 0. Initialize it with 0. So first check about j. What is j here? J is a closing bracket. J is a closing bracket, and when we have a closing bracket, the value simply become -1, and the value become negative. And what happen when we have a negative value? Simple here. If the sum is negative, it is not possible. So if we consider these braces, these closing braces, we cannot get a well-formed substring. It is true because we don't have any opening braces. We cannot do it. So if the sum is getting -1, then simply they break the loop. Break the loop. Okay. And when you break the loop, just also put the sum here as 0. And breaking the loop means start I from the next index. Okay. Now j at the starting, j and I are the same index. So first index we got here. So it will be like +1. We got +1 because it is opening braces. So when the sum is +1, it is possible or not possible. Okay, it can be or it cannot be. So for that we just increase our j. So we got a -1. So when we add the positive and negative, we got a 0. What is 0? 0 means possible. So when we get a possible string, when we actually get a possible string, what we simply do is we just calculate the length j minus I plus 1 and compare it with the best length. As simple as that. We do it every time. This is a well-formed one. This portion is a well-formed one. This portion is a well-formed one. So now our sum is 0. Okay. So increase our j. J is a positive one as because it is a opening bracket. So it is +1. J because it is +1. J, and now we increase the j because it is a positive one. It is possible or not. So we increase our j. Okay. So in the previous term, the length or the maximum length will become 2. Okay. J minus I plus 1. So now we got j, and this is a -1, and simply implies it to 0. So when I hit 0, it is possible. So j minus I plus 1. And if we go here 0, it is 0, 0, 1, 2, 3, 4. So 4 minus 1 plus 1, 4 minus 1 plus 1, which is nothing but 4. It is the maximum one, so we update our maximum. Okay, now we increase j. So the sum become again, when it become -1, we just break the loop. Break the loop. Okay. So we just break the loop here and initialize sum again with 0. Break the loop, increase it, put j here, and simply again do the same loop. Again do the same loop, and we actually get our answer. So this is our main thing. This our main idea. This is the brute force solution. Even the optimized one uses this same formula. Okay, not exactly similar, but a similar one. So let's visualize it. Okay, so just move it. Find the longest contiguous substring that has a valid bracket sequence. A substring is a valid if and only if its running balance never dip below 0 and ends exactly 0. Never dip below 0 means less than 0 and exactly 0 means 0. First we start with the I. Okay, just give me a minute. Okay, so my throat has some problem. So let's start with our balance 0. J as 0 and clearly says balance is -1 less than 0. A closer with nothings to open. This is a good line. So if the balance -1, it means we reach a closer with nothing, 0 opens. So you don't get any open one. So no extension. So we upgrade our value. We got a valid value. We got the length. We again got a value. It is a +1. Then we again got a -1, we calculate the total value. Then again it is 0, a closer with nothings to open, a closer with nothings to open, then we simply just go there. Similarly, a closer with nothings to open, then we again got a valid, but the size is 2 and we need a longer one. So we use 2 loops here. Okay, so let's do a practice here. So first take a function. It is a string as input, so s as input. So first take the base or the answer at 0. Now for I, starting from 0 to n minus 1, to every element, n minus 1. If s of j is equal this opening bracket, okay, if the character we match is opening bracket, then simply take the sum or balance plus plus, and we have to initialize the balance here. And why we initialize the balance here? So every time the loop breaks, when we encounter a negative one, it just automatically initialize the balance against with 0. Okay, or else balance minus minus. Okay, so now if anyhow, okay, here also you have to check for every step. We have to check this thing. So there is also for every step we have to check this. So we use another if statement here, which is nothing but if balance is less than 0, if balance anytime become less than 0, then simply break. And if anytime the balance is equal to 0, if anytime the balance is equal to 0, then simply update the best. Update the best. And which is nothing but j minus I plus 1. Update our length or best and simply return the, this is our pseudocode. Okay, we nailed it. So this is our, this is our pseudocode, and now write the full version of code here. First take the size, which is test.size, and take answer, let's take it at max length here, initialize with 0, it will be more specific towards the answer. So for int I equal to 0, I less than n, I plus plus. So this is our first loop. Then initialize, under this loop initialize a balance which is now at 0, and a for loop starting from 0, not 0, starting from I till the last value, and if s of j, s of j is equal to this opening bracket, then simply say balance plus plus. Okay, else simply balance minus minus. Okay, so if opening bracket we will increase the value by plus 1, and if closing bracket then we decrease the value by 1. If any cases, this is our main condition, if any cases this balance become, it simply means we uh, or rather just put it here, we encounter an bracket with without an opening bracket. Counter a closing bracket without an opening bracket, it simply means break the loop. Simply means break the loop. If any cases the balance becomes 0, it simply means we reach our valid ones. So simply when we reach our valid ones, so simply get the length, which is nothing but maximum length is max of max length comma j minus I plus 1, and simply at the end return the max length. Let's run it and check it if it's working or not. Okay, it gives a TLE for last two cases or not. 234 cases passed. This is the last test case which we cannot pass. For that one test case, we have to find the optimal solution. I think this will give us a no, because there are too many opening braces. I don't found any closing brackets. But this is too long, too long. You can use custom test cases also. So if we put it here and just run it and not submit, let's see what happens. Invalid test case. There are two inverted commas. Let's check it. It's working. It's working here. It should work. Okay, let's not go. Let's go to our optimal solution. Let's build something optimal. Okay, so you can use this solution because I am using height to just understand it. Otherwise you can just put here open solution, it will automatically open. If you go and hide solution, it will automatically hide open one. Okay, so I just move this, so the top one is always hide. So if I need anything to show it, I just do it. So this is our brute force solution. Okay, let's go to the optimal one. Okay, but give me a minute. So my throat had a problem. So Now let's visualize it with the stack index. Okay, so I think the stack visualization will be better here rather than going to scale it draw. So we will take a stack, and before that, the time complexity will be big of n for n square for the brute force solution, and the space complexity will become big of 1. Why n square? Because we are using two loops here. Okay, so now goes to our index based on stack. Okay, index stack with base. Okay, so we take a stack, we take a stack here, simple stack. Now what is our first portion? First we have to enter a -1 to the stack. It is a base element. It is the base. This -1 is our base. This -1 is our base. Why? We'll discuss it later. Actually, in any cases, actually let's do it here. So uh, our rather this is our stack, and if we put -1 here and then 0 here, okay, which is our index, then we put 1 here, 1 here. Okay, now we have to pop it at 1. Suppose this is our solution. Okay, this is our thing. So 0th index has this, 1 index has this. So for this stack, who in this thing we are doing this +1 for this opening one and -1 for this closing one. So for the same principle, for it, simple as that. Although we have to check some condition every time we pop, because maybe sometimes the stack is empty, or but first we have to check this. Okay, so when we push this element, it is as 0. When we go through this element, we have to pop this element. Okay, so now our index at 1. So what is the length of this string is 2. Length is 2, but how could we get? We have 1, and what is our stack top element? -1. So 1 minus of -1, which is nothing but 2. For the calculation of the length efficiently, we are using this -1. Okay, so no worries for that. And for this thing also, the -1 automatically get popped up when we reach anything. The first one, if it is a closing one, we easily pop that element from the stack. Okay, so let's visualize it. We take -1 at the starting, push -1 the initialized base, the index before a string. A valid run ending at I has a length of I minus index below it. Okay, so I minus -1. So 1 minus -1, it will become 2. So 2 minus -1, it will become 3. 0, 1, 2. This is our length. Although this is not possible because 3 is there. So let's suppose 4. 0, 1, 2, 3. So 3 minus or -1, it is nothing but 4. So we have to add 4 to here. Simple as that. Let's see, we encounter a closing bracket. So pop, we remove the -1. The stack is empty, unmatched. Every valid run after the ith, push I equal to 0 to the new base. Okay, push I equal to 0 to the new base. So if any time, make the stack empty. The stack is getting empty. Just put 0, because 0 is our starting index. So just put 0 here. Put 0. If any time the stack become empty, we store value -1 here, but when we reach the closing bracket, we just pop the value, and because we pop the value, the stack became empty, and the stack became empty, so we insert 0 here. So we got a opening braces, push it. Now we got a closing bracket, pop it. And what is the current value of I? 2. What is the current value of I? Check it here. What is the current value of I? 2. What is the current value of I? 2. So 2 minus stack top, which is 0. 2 minus 0, 0. What is our length? Our length is 2. What is our length? Our length is 2. So this is our value. So the length is 2. The length is 2. The length will become 2. Okay. Now another opening bracket, we push it. Another closing bracket, we pop it. Now where is our I here? I at 4. So 4 minus 0, it is 4. So we got our length as 4. We got our length as 4. And again we pop the value. In this case we only have 0 here, 0 here. But when you go to the next, we pop the value. And when we pop the value, we get a nothing. So we just have to push that I. Previously I make a mistake. I said we should push 0, but this is not 0. This is actually I. And why I? Because if any time, let's suppose, we just have to remove that previous one, because that is not in our consideration for a string length. So we just have to push that. We just have to pop that. So we start our index I from here. So when we remove that 4 from this 0, inside between 4 and 0, but 4. But when we reach to 5, and now we cannot make. So after 5, we have to check the after 5 elements to to get the valid indexes, and we have to insert 5 here. Okay, which is our new base. See here, pop, remove 0, the stack is empty. This closing bracket is unmatched. Every valid run must start after it. So every valid run must start after this closing bracket, which we cannot consider in a valid run. So we just push the I here as a new base, and we get our best result. So let's start writing our pseudocode. We are getting a function s, and take the best is nothing but 0 at the starting. Of Let's take a stack st, which is and initialize with -1, and stack initialize with -1 as base. So start a loop starting from 0 till the end, and if anytime the s of I is equal to the opening bracket, so just push the index of the opening bracket, just push the index of the opening bracket, else not a opening bracket, it is a closing bracket, as simple as that. So pop it. So st dot pop. So pop the element, as simple. But if the stack become empty, if stack empty, if the stack become empty, then simply the current base, which is nothing but the current index. Also, when we pop, we have to calculate the maximum, which is based here, which is nothing but based, which is nothing but the maximum of based minus I minus st dot top. Okay, and return the best one. Our pseudocode. Let's evaluate it. We nailed it. So this is our optimal pseudocode. This is our optimal pseudocode. Okay, now let's write the full code according to it. First, we need to take the size, which is nothing but s dot size, and then we need a stack of integer type, which is nothing but st, and uh, and now we need a answer, which is nothing but maximum length as 0. Just give me a time, there is a storm there. Okay, now make a for loop from the starting int I from the starting till the end. Okay, so now uh, if the s of I is nothing but a open bracket, simply say st dot push the current index. Else else means simply we have to pop it. First pop this. First pop everything from the stack, and if we make the stack empty, then simply dot push the current index. Now the I became our current base. Okay, so uh, we have to now calculate the base, but we make a mistake. St dot push -1, we don't initialize our base. So after that, simply calculate our max length, which is nothing but maximum length equal to I minus st dot top. So from the top element and from the I, we got our maximum, and at the end just return the maximum length. Now, okay, it's spelling mistake. See that one case, we passed that one case, that single case, which is nothing but uh, I think, yes, this one, we passed this one. So this is our solution, and we use a simply one loop here, so the time complexity will become big of n, and we use a stack here, so we can easily get a maximum, so big of n. The time and space both here are big of n. So this is our solution on the question longest valid parenthesis using the stack approach. Use this link to get a 7-day free trial. Use this platform. It is a very good platform. Use this platform, and now use to 7-day free trial. Use this platform. Nice platform at dsa.chaicode.com. Thank you. Thank you very much.